Hi, welcome to Dissolve Chemistry. Let us continue our discussion on this thermodynamics with new topic, that is enthalpy, a very important thermodynamic function. Okay, so let us consider a system, okay, which is closed one, where volume is kept constant. Okay, there is a system, we call it as closed system, where volume is fixed. Okay, and it contains 1 mole of gas, right? So now what we will do is volume constant. Now suppose if you give the heat energy to such system, then what happens? So all the heat energy absorbed by the system will lead to change in the internal energy of the system. Okay, so therefore a Q amount of heat given at constant volume leads to change in the internal energy of the system, means all is being converted into internal energy of the system. Let us consider another system where the gas is allowed to undergo free expansion, means it can change its volume. Okay, so meaning is what? The system is allowed to operate at a constant pressure. The external pressure is constant. Now what you do, similarly you give the same amount of heat energy. Okay, now what happens? It will absorb the heat energy. Then the certain amount of heat energy is being utilized to increase its internal energy, and the rest of the energy is being utilized to expand. Okay, so now, as the gas expands, meaning is what? That we can notice by the movement of the piston in the upward direction. In such situation, the change in internal energy will be less than the amount of heat given to the system. What is the reason for that? Because it is utilizing certain amount of energy to do the expansion work. So therefore, now the heat given to the system, we call it as what? The heat given at constant pressure we call. Okay, as it is not equal to the change in internal energy, so certain amount of energy is given back to the surrounding in the form of expansion work. So therefore you write QP is equal to what? Delta U plus W, means certain amount of the work is being done. Now whatever the heat which is given at constant pressure to the system, we call that as what? Enthalpy change. QP is equal to new term we are going to introduce, that is change in enthalpy. Okay, so whatever the Q amount of heat is absorbed at constant pressure by the system, then that Q amount of heat we call it as what? Change in enthalpy of the system. Okay, and that enthalpy, let us define the term. Okay, so this enthalpy is defined as H is equal to U plus PV. Okay, pressure volume work. Already we have discussed this. What do you mean by PV work? Now when you look into the definition of this enthalpy, we say that it is an internal energy of the system, and this is pressure and volume. Okay, that is nothing but work. Now when you look into all these terms, all are what? State functions, meaning is what? So they all depend upon the initial and final state of the system, but not on the way the change has been brought in the system. So therefore obviously your enthalpy is also a state function. Okay, enthalpy is also a state function. So therefore we cannot determine the exact value of the enthalpy. We can determine the change in enthalpy because it is a state function. So therefore, let us consider the two conditions. Initially your enthalpy of the system changes from H1 to H2 if we consider, then internal energy of the system will change from U1 to U2, pressure from, okay, pressure anyway it is constant, let us take it as P as it is, or you can write P1 to P2, we will write first, we will then later will change. So we will change from V1 to V2, we will take. Then how we will write? H1 is equal to U1 plus P1 V1, H2 is equal to U2 plus P2 V2, right? Change in enthalpy, that is nothing but H2 minus H1, that is equal to, so what we can write? U2 plus P2 V2 minus U1 plus P1 V1. Okay, so that is how we will write. Now take the same terms on the same side, so therefore delta H is equal to U2 minus U1 P2 V2 minus P1 V1. Okay. So then next what it happens to be? So delta U plus delta PV, delta H is equal to. We know that the pressure, anyhow the heat given at constant pressure or heat evolved absorbed at constant pressure, we called it as what? Enthalpy change. So therefore your pressure is constant, you take out of this. So then what you will be getting? Delta H is equal to delta U plus P delta V. Now so when the enthalpy changes, meaning is what? Our system is doing some work, expansion work it is doing, that is our volume change will occur in this case. So now in most of the cases what happens? So the change or work done by the gas, it is always not in the form of change in volume. When it is in the form of change in number of gaseous moles, so then we will take, say for example, we will consider this equation and we will alter it. So therefore delta H is equal to delta U plus delta PV. From ideal gas equation, PV is equal to nRT. So therefore let us substitute nRT in place of PV. So therefore delta H is equal to delta U plus delta nRT. Okay, at a given temperature, right? The change in enthalpy depends upon what? Change in number of moles of gaseous reactants and products. And whereas R represents the significance of R, that is gas constant. Okay, so its value is found to be 8.314 joule per Kelvin per mole. So its significance is, it means each mole of gas at per Kelvin temperature does 8.31 joules of work. Okay, so therefore change in number of moles of gaseous reactants and products, if it is there, so then directly if we multiply that number with this gas constant and constant temperature, so then directly we will get the work done, okay, in the form of what? nRT. Now if, okay, so then whenever there is a change in number of moles of gaseous reactants and products is given in the problem, then you have to use this formula delta H is equal to delta U plus delta NGRT. Suppose if it is given in terms of change in volume, then you have to use delta H is equal to delta U plus P delta V, right? Okay, now let us talk about how this change in enthalpy we relate with the change in internal energy. See here, first condition we will take delta H will be equal to delta U under following conditions. First one is, if your reactants and products are involving solids and liquids, then the change in volume is negligible. So therefore whatever the change in enthalpy is there, almost it is equal to change in internal energy. Condition number 1 is when reactants and products are solids or liquids, then what? Change in volume is negligible. Then what happens? That whole term what we see, delta H is equal to delta U plus P delta V. Change in volume is negligible means this whole term becomes 0. So therefore your delta H will be equal to delta U. Next we will see when this delta H becomes equals to delta U is that suppose if the reactants and products are gaseous, okay, and change in number of reactants and products is 0, then also what happens? Delta H becomes equal to delta U. We will take the example. Okay, we will consider a very simple example for change in number of reactants and products is 0. That is the combination of H2 plus Cl2 gas. Okay, 1 mole of H2 combines with 1 mole of Cl2 to give 2 moles of HCl gas. Okay, so now the reactants, number of moles of reactants will be how much? It is equal to 2 moles, and number of gaseous products is equal to how much? 2 moles. So therefore delta Ng is equal to Np minus Nr, number of moles of gaseous product minus number of moles of gaseous reactants. So therefore you substitute 2 minus 2, so therefore delta Ng is equal to how much? 0. So therefore when I substitute that in equation, delta H is equal to delta U plus delta Ng RT. So then what I will get? Delta U plus 0 into R into T. So therefore delta H becomes once again equal to delta U. Now second case we will take when the change in enthalpy is greater than change in internal energy. Now again it depends upon what? The number of gaseous products and number of gaseous reactants. Now suppose consider a reaction that is PCl5 decomposes to give PCl3 plus Cl2 gas. Okay, so now 1 mole of reactant reacting or undergoing decomposition to give 2 moles of product. Number of moles of products is 2 moles. Number of moles of reactants is 1 mole. So therefore let us write delta H is equal to delta U plus delta Ng RT. So where delta Ng is equal to what it is? Number of gaseous products, that is 2 moles, minus reactants 1 mole. So therefore delta Ng is equal to what? It becomes 1. So then you substitute 1 in that. So therefore delta H is equal to delta U plus RT. Okay, so therefore delta H is greater than what? Delta U by the factor product of gas constant and the given temperature. Okay, this is the condition where our delta H will be greater than change in internal energy. Now last condition we will see, change in enthalpy is less than change in internal energy. So now consider reaction, that is formation of ammonia plus 3 moles of H2, it combines to give what? 2 moles of ammonia. Reversibility is going to combine to give 2 moles of ammonia. Now look at the number of moles of gaseous reactants is equal to 1 plus 3. So therefore 4 moles are there. Okay, similarly number of moles of gaseous products will be 2 moles. Okay, so then the change in, right, number of moles of gaseous reactants and product will be Np minus Nr, where Np is 2, Nr is 4, so therefore it will be minus 2. Delta Ng value is negative. So therefore when we substitute in the equation, delta H is equal to delta U minus 2 into RT. So therefore delta U is equal to delta H plus 2 RT. Right? So that means our internal energy is greater than change in enthalpy by this factor 2 RT. Okay, so therefore change in enthalpy is less than change in internal energy of the system under such conditions when the number of reacting moles of gaseous reactants are greater than compared to number of products. Okay, now we will talk about, so we have understood what do you mean by this enthalpy, why we should use this term. Okay, now we will look into the justification that why we should use this the amount of heat given to the system or given out by the system at constant pressure as a change in enthalpy. Okay, so why we have to use the new term, so that we will justify. Okay, QP. Now let us consider a system, okay, so which is free to expand, meaning is what, it is working at constant external pressure. Now if you give the Q amount of heat, now we call it as what, amount of heat given at a constant pressure. So now what happens, the internal energy will change, then it will do certain work. So therefore delta H is equal to, you write, so change in internal energy plus P delta V, we will write. Okay, our volume will change from, say for example here to here, V1 to V2, so you can consider. So now delta H is equal to delta U plus P delta V, and we know that, okay, our delta U is what? Delta U is change in internal energy. You remember isobaric process that we have discussed in our previous video of thermodynamics. So change in internal energy in isobaric process is what? So that is P minus W plus P delta V, you keep it as it is. Now delta H is equal to QP, amount of heat absorbed at constant pressure, minus P delta V, we will take P delta V plus P delta V. So therefore these two will get cancelled, so therefore your delta H is equal to QP. So this is how we are going to prove that change in enthalpy is always equal to the heat content of the system at constant pressure. Okay, maybe absorbed or maybe given out. Okay, this is all about enthalpy. Right, I hope you have understood all the concept what we have discussed in this video. Please subscribe our channel and don't forget to like it and share with your friends. Thank you for watching.